Let's discuss the performance of the ADF and KPSS tests. First, let's review what the ADF and KPSS tests are. Jumping into the ADF, we recall that's the augmented Dickey-Fuller test, where HO is that the model contains a unit root, which is consistent with non-stationary process, and HA is that the model does not contain a unit root, which is consistent with a stationary process. In order to perform this test, we'll generate a test statistic tau from the data, and the rejection region will be that we will reject HO if tau is less than our critical value, which we'll call D sub alpha here, and we will show in the code how to find the test statistic and as well how to find the critical value so we can make this decision. So we'll do that right now through an example. So here we'll see that we have this ADF test. And move this down for now just so we can focus on this part. You're going to need the IRCA package and the TSWGE package. And we need from the TSWGE package, we're going to generate a realization that we know comes from a process with a unit root. That's what this D equals 1 is there. So we know that that R is a realization that comes from a non-stationary process once again, having a unit root. Thus, for the ADF test, it will make the quote correct decision if it fails to reject the null, meaning that tau is less than the critical value. So I'm going to go ahead and run that. There's our realization. So after we have the realization, we can run the test, and that's what ur.df, that's the Dickey-Fuller test from the IRCA package. We give it the realization. We say we want to account for drift. We tell it to select the lags via AIC, and we just ran the ADF test right there. But the results are all tied up in h.df. So that's what it looks like when you grab the results. This is our tau, negative 1.4087. So I'm going to grab that, and you can see just like that. That is it's just the index, the first index. And then the critical values are also stored in this function, not displayed in the default output, but I just wanted to show you all of them. So that's the 1% alpha, 5% alpha, 10% alpha, and we're looking at the tau 2 one. So if I want at the alpha equals 5% level, we're looking at a critical value of negative 2.89, which of course negative 1.4 is greater than negative 2.89. So coming back over here, we would fail to reject, right? We only reject if tau is less than alpha, and our tau of negative 1.408 is greater than negative 2.89. So that's why I've got this piece here. And so that one would make the correct decision. We knew it came from a non-stationary process. It failed to reject the null that the model came from a non-stationary process, had this unit root. So in that case, it made the right decision. Great. But what we want to do is evaluate the performance of this test. We want to look to see on average how often does it make the right decision. And so through different realizations, we've come up with this table where we can see here at the ADF test for different realizations, there's different amount of information, of course, about the process that generated that realization. So we've got here n equals 100, we'll call that relatively small realization, 200, 500, and 10,000. Noting here in the book, I think we have 4,000. So you can look at this either way. It's a good exercise to just try this out with 4,000 and 10,000. But I think we'll find pretty much the same result here at that level, at that size of realization. But here, when we ran it, it can be seed dependent. It kind of underperformed here, right? It's at an alpha 0.05. It should be making the wrong decision 5% of the time. And making the right decision 95% of the time. So let's check this 91% that we have here. And the way we're going to do this is that's how you'd run the test one time. That's how we'd run it in reality. But if we're being data scientists and really evaluating the test rather than just using it practically, we might set up a loop like this. And so what that does, again, we're going to need the IRCA package. We've already loaded TSWGE. We've already loaded IRCA. So what we're going to do is do this test 100 times in this case and generate 100 realizations and see just at random that we know have a unit root and then see how often this test makes the right decision. Maybe it makes it all the time. We'll see. So that's what we're going to do here. We need to hold the results. I've got 100. I've got essentially an array here with 100 cells, one for each time that we're going to generate a realization and see how well the test does. Generate a realization, see how well the test does. So that's what this is. So for I in 1 to 100, we are, in fact, let's make this 1,000, just so we don't confound our hundreds together. So I'm going to do this 1,000 times. I'm going to generate 1,000 realizations for each one. I'm going to look at the augmented Dickey-Fuller test to see if it made the right decision. And overall, I'm going to look at the percentage of right decisions it made. And that's what this is looking at, the percentage of right decisions that it makes overall when our realization size is 100. So that's what we're doing here. So for we're going to do this 1,000 times. What are we going to do 1,000 times? I'm going to take this set seed out so we can see it. I'm going to generate a realization. So when I equals 1, I'm going to generate a realization. It's going to be 100 units long.